Let's prove by contradiction that the square root of 4n minus 2 is irrational, given that n is a positive integer. So let's assume the opposite. Let's assume that it is rational. So that means there exists an a and b where they're both integers and b does not equal to 0, such that this can be written as a fraction, where the GCD of a and b is equal to 1. And so what this means is you took the square root of 4n minus 2 and wrote it as a simplified fraction. So a over b cannot be simplified further. Okay, now let's square both sides, and let's multiply both sides by b squared. Clearly, we can factor out a 2b squared from both of them. And what we see is that 2b squared is even, since we're multiplying by 2. 2n minus 1 is odd. And so even times an odd is an even. So this means that a squared is even, which means a also has to be even. Okay. Now, since a is even, we're going to let a equal 2k for some integer k. Let's plug it in to this equation right here. So a squared would just be 2k quantity squared equals 2b squared times 2n minus 1. 2k squared is 4k squared equals 2b squared times 2n minus 1. Now from here, I can divide by 2, get 2k squared equals b squared times 2n minus 1. We know that this is obviously even because we're multiplying by 2. This is odd because it's 2n is even minus 1 is odd. So this has to be an even number, because what multiplied by an odd number is even? Well, that has to be even. So this means that b squared is even, so b is also even. So what we've shown is that a is even, b is even. So when we look at a over b, this is no longer simplified form. We know that the GCD of a and b is at least 2 because they're both even. And that contradicts the assumption that it was in simplest form. So there's our contradiction, and we conclude that 4n minus 2, the square root of 4n minus 2 has to be irrational.